Hi guys, welcome to a review video for our end of course exam. In this video, we'll be going over periodic trends, guys. So periodic trends, there's a little trick to remember them. There is a total of 7 periodic trends that we need to know. The first 2 that we're going to learn, they build up everything else. So it's very, very important that we do understand the first 2 because most of the time they will go back to those first 2. So the first one, guys, we're going to start off with is shielding. So shielding increases as you go down the energy levels. How many energy levels do we have? We have a total of 7. So we have 1, 2, 3, 4, 5, 6, and 7. As you increase shield, guys, I want you to notice what is happening to the size of the atom. So as shielding increases, you're going to notice that the size of the atom is also increasing. Your largest atom is actually going to be francium. We're going to go towards that trend later. But again, the shielding, what it does as it increases as it goes down from 1 to 7, it is just increasing, right? So the more electrons you have, the weaker the attraction is felt from the electrons to the nucleus. So more electrons equals more shielding. Remember, protons are positive and electrons are negative. These are opposite charges and opposites attract. So the more shields that you have, the further away your electrons are from the nucleus, and there's a less attraction to it because they're too far away to feel an attraction. On the other hand, that is shielding. That is one of our first primary trends. You have ZEF, which is effective nuclear charge. Guys, effective nuclear charge is the attraction felt from the outer electrons to the nucleus. So effective nuclear charge, again, it increases by the group. Groups are very, very important. Effective nuclear charge goes from 1 to 8. So I'm sure you can make the connection that effective nuclear charge is weakest in group 1 and strongest in group 8. So that is your effective nuclear charge, and it is the attraction felt by the outer electrons. What happens, guys, is you go further to group 8, you have more protons, right? So we're still in the, let's take, for example, lithium, and let's take, for example, neon. So we have lithium, which is a ZEF of 1. And then we have neon, which is a ZEF of 8. So what is the big difference, right? They both have 2 energy levels. We have 1 and we have 2. We have 1 and we have 2. But in the center, lithium is going to have 3 protons. And neon is going to have 10 protons, guys. So remember, that attraction felt by the positive to the negative is going to increase, and there's going to be more attraction in neon because it has a lot more positive ions, right? So all those positive ions are going to pull on those electrons, and that's why the effective nuclear charge increases as you go further to the right. So again, shielding and effective nuclear charge are OGs. Those are the 2 trends that we always go back to. Now let's connect them, guys. Here we have ionization energy. Ionization energy is the energy required to remove a valence electron. Something special about ionization energy, guys, is that it actually includes, so whenever I think of ionization energy includes the noble gases. So it includes noble gases, right? What happens is that your noble gases have a group number of 8. They do not want to give up an electron. Why? Because they have 8 valence electrons, guys. They're meeting their perfect number, right? So ionization energy increases with the group number. So you have 1, 2, 3, 4, 5, 6, 7, and 8, right? So your ionization energy is strongest in your noble gases because they are not going to give up that valence electron. That is their whole deal. We have a full octet and we're not going to give it up. So that is ionization energy. It follows a very common trend. It goes up and to the right. So for this one, guys, which element has a higher ionization energy? You have aluminum, and then you have bromine. Bromine is down here. Remember, the trend for ionization energy is up and to the right. So for this one, group 3 only has those 3 in the center. So bromine would have a better one. Next we have is potassium and calcium. it would be calcium. So the further you are in the group, from 1, 2, 3, 4, 5, 6, and 7, that is your stronger ionization energy. And magnesium or lithium, it would be magnesium. So right here, guys, once I upload the exemplar, you have the reasoning. So group 7, group 3, group 2, group 1, group 2, group 1, all of that, guys. Lastly, you have electronegativity. So electronegativity, guys, like it says it in the name electron, how you attract electrons. This one is a little bit weird, not weird, but it's different because electronegativity, so when you write electronegativity, it excludes noble gases. Noble gases, guys, do not have any electronegativity. They have their 8 valence electrons and they do not want any more electrons. They're done. They're full. Your most electronegative element is going to be fluorine with 4.0. So the closer you are to fluorine, the more electronegative your element is. So I'll repeat that one more time. The closer you are to fluorine, the more electronegative you are. So again, it increases as you go up and to the right, and it is how much an atom attracts extra electrons. So high effective nuclear charge, right, 1 through 8, and low shielding. So for this one, guys, you can practice and pause and answer the questions on your own. And here we'll have our exemplar. So again, obviously fluorine is going to have a higher electronegativity than neon because remember, our noble gases are excluded. They do not have any electronegativity. Then you have nitrogen and chlorine. The closer you are to fluorine, the more electronegative you are. Chlorine is touching fluorine. It is right on the bottom. So chlorine is more electronegative. And lastly, you have lithium or sodium. This is a trend that increases as you go up and to the right. Lithium has less shielding, so it has more attraction there. Lastly, guys, there is always a rebel. There's always a rebel in a family, right? And our rebel in our periodic trends is the atomic radius. So whenever you think of the atomic radius, think of them as being a rebel. Most of our periodic trends increase as you go up and to the right. That is not the case, right? That is not the case for atomic radius. Our atomic radius actually increases as you go to the left and down. It is the exact opposite of everything else. So what is the atomic radius? The size of the atom. Your largest atom would be francium down here because it has a lot of shields and very little protons. So this one increases as you go left or have a smaller effective nuclear charge because what's happening is you have less protons pulling you in. So because you have less protons pulling you in, what ends up happening is that atom can get larger and larger. So again, based on your shielding, here's 1 shield, 2 shield, 3 shield, 4 shield. So it makes sense, guys, that what would happen is that as you increase the shielding, right, your atom would get bigger. So that is the trend for atomic radius. Remember, radius is your rebel. It goes exactly the opposite way. Then you have ionic radius, guys. The ionic radius is the size of an ion. If you remember, an ion has a positive or a negative charge. Negative ions are bigger. Positive ions are smaller. That is the key understanding here. Your positive ions lost electrons, while your negative ions gained electrons. So they have more electrons, but they have less protons in the center, like pulling it in, right? So this ends up leading to a larger ion. So gaining electrons, more electron-electron repulsion, they're like going against each other, so it's a bigger setup. And then losing electrons, there's less electron-electron repulsion, so they're a little bit smaller. So which one has a larger atomic radius? We have scandium at +3, so we would look for scandium. But +3, instead of going forward, we would go 3 back, so that would be argon. And then we have potassium, but we would add 1, so we would go back 1. They both end up, or they're isoelectric to argon. but the one that is less positive, guys, is going to be bigger. So the one that is less positive is potassium. Our larger atomic radius would be potassium. It only lost 1 electron, while scandium lost 3. On the other hand, we have argon. So argon is Ar, and then we have, we have sulfur with a -2. So it would also be isoelectric to argon, but you add 2, right? Because you do the exact opposite. So argon, which has 2 more, right, would lead to that negative charge. That negative charge means that sulfur would be bigger. So again, which has a larger atomic radius, potassium, and then you have sulfur. Again, I'll upload this as well so you can practice it with your review video. Which has the greater radius, iodine or bromine? So iodine is right here, and bromine is right here. Remember, radius is a rebel. It goes to the left and down. So the further down you are, iodine has 5 energy levels. 1, 2, 3, 4, 5. This is iodine, while bromine only has 4. 1, 2, 3, 4. So our best answer would be iodine because it has more shielding or energy levels. I like to use the word shielding. There's your exemplar, guys. Again, it'll be on there. Here you have a practice on atomic radius. Again, you will have your exemplar. And for this last one, guys, I just really want to review with you the way that I learned and I'm able to remember periodic trends. So we know shielding increases as you go down. I'll put those in blue, shielding. That's one of our OGs. So again, the more shields you have, you go from 1, 2, 3, 4, 5, 6, and 7, right? And then on the other hand, you have effective nuclear charge, right? So your attraction. This is Zeph. One way that I learned it, guys, that really, really helps me is this. You draw an E, right? So and it goes up and to the right. Those are my trends. And it has 1, 2, 3 lines. There's 3 trends, guys, that do this. So the trend that first starts it, this is Zeph. Then you have electronegativity. Remember, electronegativity excludes, electronegativity excludes noble gases. Electronegativity is the attraction for electrons. They do not want electrons. They have enough electrons. So it excludes, electronegativity excludes the noble gases. On the other hand, you have ionization energy. So remember, ionization energy, it also has an E, electronegativity, effective nuclear charge, ionization energy. Those are my 3 E's. Ionization energy includes noble gases. So ionization energy is the energy needed to remove an electron. Noble gases, guys, are not going to want to give up an electron. They love their electrons. They have a full octet. So those are the 3. And then lastly, guys, so you have effective nuclear charge, and then you have electronegativity. Remember, electronegativity stops here. That your most electronegative element is fluorine. That's electronegativity. And then you have, as you go up into the right, you have, so ionization energy, you include noble gases. So that's ionization energy. So from there, guys, you have those trends. And then lastly, as always, our little rebel is our atomic radius. So our atomic radius does the exact opposite. Atomic radius will go left and down. It's like the black sheep. That's why I wrote it in black. So our rebel is our atomic radius. So atomic radius increases as you go left because you have less protons, right? And the center pulling it in, and as you go down because you have more shields. And that's about it, guys. I'll post up the Pear Deck with the practice questions, and you can practice those as well. And happy studying. Bye, guys.